In section 3.7, we're going to talk about points of concurrency. A point where multiple lines and segments are intersecting is called a point of concurrency. And we're going to do a bunch of different ones. The first one that we're going to talk about is one called the incenter. Now, when you have three angle bisectors of a triangle meeting, that's the incenter. That incenter, or the point that they're talking about, designated here with the red point, is equidistant from all three sides. This will allow us to inscribe a circle inside of the triangle, meaning that it will touch all three sides of that triangle. And I'll be able to see that based on your arc marks. So what you do, for example, from the far left corner of this triangle, I place my compass point. From this compass point, I draw an arc. Once I've drawn that arc, I stretch out my compass, and from each of those intersections, I'm going to place my compass point, stretch it out past the triangle, and make an arc out in space. So I did that from the bottom intersection point. I have my compass on the top now, stretch it out again in orange, and I'll see that those two parts intersect. I connect the vertex through the intersection of those two arcs, and I have one angle bisector. This is something we did in a previous lesson. I can pick another vertex. Let's say I pick the bottom right vertex, and I do this process again. I put my compass point on the right vertex, stretch out my compass, make an arc. From the two arc marks, I stretch my compass out past the triangle and make an arc mark in space. So I'm doing the top part of the intersection of the blue and the triangle, and I make an arc out in space. I place my compass without changing anything on the bottom intersection of the blue arc and the triangle, make another arc out in space. And what I notice is that these two things intersect each other. And so I'm going to connect the vertex of where I initially put my compass point through the intersecting arcs. And what I'll notice is that those two rays that I've generated are now intersecting. I can do this a third time to verify. If you've done it correctly, it's not going to be necessary, but if I do it the third time, it definitely verifies that I definitely have the incenter where I can draw this circle. So I'm just going to do it one more time. So the third time, I place my compass point on the vertex of the top, stretch out my compass a little bit, and then make an arc in space. You'll notice it intersects the triangle in two spots. From the intersection of those two spots, I'm going to take my compass point, put it on the intersection, stretch it out past the triangle, and make an arc. I do it again from the other intersection of the brown arc and the triangle, make another arc. I notice that they intersect. I connect the vertex through the arc intersections, and again, where they all meet is called the incenter. I place my compass point on the incenter, stretch it out to the side of the triangle, and I will generate a circle that touches all three sides. That's called the incenter, created with the point of concurrency by angle bisectors. The second kind of point of concurrency that we're going to talk about is one called the circumcenter. The circumcenter is using perpendicular bisectors. So I'll demo with two this time instead of three. Again, the third one verifies, but it's the perpendicular bisectors that create the circumcenter. The circumcenter is a point that, when generated, will allow you to use all three vertices of the triangle to draw a circle around the triangle. And again, that's with perpendicular bisectors. So what I'm going to do is I'm going to take my compass and generate three perpendicular bisectors. So to do the first one, for example, let's say I'm looking at the bottom of the triangle. I take my compass and I put it on one end of the triangle, and I draw an arc out in space. When I draw this arc out in space, it'll look something like this. I go past halfway on the bottom of the triangle. Looks like this. Then I take my compass and I do it again from the other point on the bottom of the triangle. My compass is already stretched out, so I'll make another arc out in space. When I finish, what I will do is I will connect the two intersections of those arcs, and I will have a perpendicular bisector of the bottom of the triangle. I can choose any other side to do this with, and that'll give me the point of concurrency. So let's say that I pick the top left side of the triangle. From the top left side of the triangle, I will pick one of the points on that side. Let's say again it's the left point over here. I stretch my compass past halfway, and I make an arc out in space. When I make this arc out in space, one of the things that I'll notice is that if I go to the other place for this top left side and place my compass point there, my compass is already stretched out, so I make another arc from the other side. And when I have these two intersecting arcs, I draw the connecting line, and I'm sorry but my two arc marks, being distracted by a student trying to get into my classroom, are a little bit off, but what you'll notice is that these two arc marks intersect, and you draw the line that goes through those two intersecting arcs. What happens is this generates that point that I was talking about called the circumcenter. You then take your compass, put it on that point that's the intersection of the two lines that you've just drawn that were the perpendicular bisectors, touch any one of the vertices of the circle, and you should be able to draw a circle that is exactly around the whole triangle. That's called a circumscribed circle. The next kind of concurrency point that we're going to talk about is called the orthocenter. The orthocenter is generated by using the altitudes. I'm not going to go through how to draw each of the altitudes. It works kind of like the perpendicular bisectors. It's where you do a perpendicular from a point to a line. So if you go rewatch the video that we did a little bit earlier of how to do a perpendicular from a point to a line earlier in this chapter, you'll see it. I'll do one demo and you can kind of see how this altitude is generated. Let's say I pick the top point of my triangle to make an altitude. I put my compass on the top vertex of this triangle. I stretch it out past halfway, and I make an arc out in space. From where that arc intersects the two places on the bottom side of my triangle, I place my compass point. I can restretch my compass if I want to or not, and I make an arc out in space. I do the same exact thing from the other intersection place of my arc and the bottom side of the triangle, and I make another arc. And what I will see is now that I have created a thing where I can go from the point to the intersection of those two arcs, and that's generated an altitude or a perpendicular to the line. And we did this earlier in chapter 3. And what you'll notice is where all three of these altitudes cross, there is an intersection, and that is called the orthocenter. Repeat process 3 times from each vertex. Perpendicular from a point to a line. Previously talked about in chapter 3. In this slide, we're just going to be talking about another kind of point of concurrency. It's called a centroid. It's also known as the balancing point in a triangle. It's formed by making the medians, and basically you just have to find the midpoint of a line. There are numerous ways to do that. Go watch an old video if you want to see how to do that. It's the balancing point. You can put a pin there and balance the triangle. It's also sometimes known as the center of gravity or mass. This centroid divides the medians into 2 segments, and the longer is twice the smaller, which we'll get to later. So again, the big thing I want you to know about the centroid is that it's formed by figuring out and intersecting all 3 medians. So a median is something that goes from a vertex, let's say the far left vertex, and hits the opposite side of the triangle such that you'll see that it's in the middle of that triangle side. Numerous ways to do that. And lastly, something that I'd like you to know about as a fascinating fact is something called an Euler line. An Euler line has three things in it. It has the circumcenter, it has the centroid, and it also has the orthocenter, which are all points of concurrency. The centroid divides the segment containing these 3 points in which the smaller part is half of the larger. For example, if you look here, point B is the centroid. So if I look at point B being the centroid, here's point B, it divides the segment CA in a 2-to-1 ratio. So for example, CB could be 4 and BA then would be 8. So CB is 4, BA is 8. It's a 2-to-1 ratio, and that always happens when you have something called an Euler line. You're not going to have to construct that, just an interesting fact.